Chessex. 20. 20. 20. That's strange. This dice was performing a lot more random a while back. So, this came up to this point, but we have a 2 and a 20 over here, 18, 4, and 14. The water has a little bit more salt than normal in it, because Chessex dice are a little heavier, so I've been working on my solution. We have the same point again. Let's drop this one again. And one more time we have this. Well, actually, no, this is a different point, which is good. So it's a little bit more random. And I'm switching solution to a heavier solution to handle the heavier Chessex dice. Chessex Part 2. Sorry about the break. I had to add more Epsom salt to the water. Some Chessex dice are heavier than others. It's because they're made in different factories. So to get them to float, you have to adjust your water a little bit. You can actually see the salt floating there too. So flip this one. It pops up to the 20. 20. And back up to the 22 side. It's showing the edges like that because there's a lot more salt in the water than I need. Okay, we got a 20 as well. Pop back up to a 20. Got a 20 again. And a 20 once more. Let's get this one floating. Okay, that one's a 1. And we got a 1 again. And a 1 once more. Chessex have, from all my testing so far, have been notorious for floating either to a 1 or a 20. And when I went to measure the Chessex dice, it actually 1 and 20 was the widest point in the die. And what that could affect was be created is like with a boat. You know, the boat has to go deep to hold down stability. So because of the length of the die there, that could cause it to float that way. Not necessarily roll that way. These are WizDice. They are a lot lighter than Gamescience dice, so you'll need about 2 tablespoons to almost a half a cup of water. I'm getting them to float with the point out here, but I'm going to give each one 3 spins. I have a total of 5 dice. Right now, this is on the 10 with a little bit on the 8. 1 spin. Back to the 10 and the 8. Again to the 10, 8, a little bit on the 17. And the 10, 8 again. Shows me that there may be a bubble, because these are plastic molded injected, better than Chessex dice. And that would be a vacuum bubble. Okay, so we've got a 7 showing primary. Let's roll it again. And we've got the 7 and a 1. Again, we've got a 7 and the 1. And the 7 and the 1. Okay, this time we have a 19 showing as primary. And it's popped back up to the 19 and the 9 again. And back to the 19 and 9. And the 19 and 9 once more. Okay, this floats up to the 18. And to the 7. To the 11. And to the 9. This one seems fairly random. I would trust this one in gameplay. Okay, we get a tip, but we got a 10, a 17, and an 8. So let's remember that. There's your 10, 17, and 8 again. Your 10, 17, and 8. I'll get a good whack this time. And you've got a 10, 17, and 8 one last time. So out of the WizDice, the only one that is actually showing any good is the semi-translucent one. This is white. Reminds me of lemonade. The other ones are opaque, but the thing about WizDice is they are completely plastic molded and injected, unlike the Chessex dice. These dice may have vacuum bubbles underneath those numbers, which the water test would show that the water test will show that the is more sensitive to vacuum bubbles. 5, 7, 19, 4, 14, 4. 4, 9, 18. 20, 5, 20. 18, 14, and 7. The Gamescience, they perform fairly well. There are some that popped up on the same number twice, but not in a row, which could have just been the way I was spinning it. The interesting thing I've noticed about Gamescience dice is when they are floating in the water. I've watched them. They'll start out on one side and they'll just rotate to another side, which is very interesting. Kind of like it's not favoring any side and it's just shifting to the water. That's with it sitting at rest on my desk in a closed container. Okay, everybody, as you know, I've been measuring dice, and on this sheet that I've got displayed here, I've done this for each different manufacturer dice that we're testing out here. And at the top part is I've laid the dice down flat on the paper, and I traced it with a pencil, and then I measured it, and then I inked it so you can see it better. So my inking is a little bit off. And if y'all can come up with a better way to do that, that would be great. And just let me know, and I'll try to redo it. And the bottom part is a measurement of thickness between the pairs of sides of the dice. So let's look at that first. Okay, now these are Chessex dice here, and the thicker pairs are marked in red, and the thinner pairs are marked in yellow. Now, let's see here. You'll also notice down at the bottom I did a difference between the thickest and thinnest sides. So right here, and if we look at the first one, that is 22 hundredths of an inch difference between this side and this side. and I've done it for all these dice here. The worst one was this ivory one, and it's a 20th of an inch off. And compared to the rest of the dice, the best one was this gray die that I had here, and it was 1500ths of an inch off. Now I'll let you know what I did was my calipers do go to 10 thousandths of a inch, but I dropped the last number off since it does it in fives on the last number, and I went just to a thousandth of an inch. It's a little bit more accurate that way. Now, so you can see here that there is a difference between sides, and let me explain what happens. Is when your dice are being manufactured in the mold, when they pop out of the mold, they're actually pretty accurate. They've got the straight edges, like the Gamescience dice, and this is through all manufacturers. But what happens is they want to make their dice look pretty, so and have their numbers eat. So they take the dice and put them in a basket, dip them in paint, pull them out, let them dry, throw them into a rock tumbler, and they tumble them for a while. And then they pull them out just to make sure all the paint's off of them except for what's in the numbers. And then they, dust them off and throw them in a different rock tumbler that has a finer polishing media, and they polish your dice. And then they pull them out and then they sell them to you. But what happens is it rounds the edges off and it can mess the sides up a little bit. And as you can see here, in the thicker and the thinnest, these are all supposed to be the same, but they're not because of some sides get wore off more than others. And we'll go a little bit more into that here with the next set of dice in just a moment. But let's switch to the other sheet again. Now, as you can tell, what I've done here on this Chessex dice is again, I've marked the thicker sides with, or the thicker measurements with red, and this time the thinnest with blue. And then I went ahead and come up with the area for each of these dice. And you'll notice that if you have a thicker measurement, your area is actually smaller than the part of the dice with the thinnest measurement. So the bigger area on the thinnest measurement is going to catch the roll easier, and you're going to hit the 3, or like on this first die, you're going to hit the 3 or 18 easier than you are going to hit the 8 and the 13, just because again of the it's closer to the center of gravity, and your area of your face is bigger. Now let me switch back to the other sheet. I forgot to point something out here. If you notice that on this gray die, the thicker sides are the 120 sides. Now you notice in the water test, either 20 comes up a lot, or I've seen some come up with 1. And what's happening here is kind of an effect like a boat. If you have a boat in the water, the bottom part of the boat is called the keel, and the keel goes into the water, and that stabilizes the boat. So what's happening to your die when you put it in the water, the heavier, longer part is going into the water and stabilizing the die floating into the water. So you have a kind of a keel. It's a boat effect. Now, why is the one heavier than a 20? Because less plastic is taken out of that side compared to the 20 side. And that's why your 20 keeps coming up. I've measured about 25 Chessex dice this way, and 23 of them, their thickness is, their thickest part is the 120. So I don't know why that is, but those dice are going to roll a 1 or a 20 less. So and they're going to favor other sides of the dice more than they are going to favor the 1 or the 20. Now let me see here. Let me go ahead and get swapped out to another set of dice. Now I did 3 different types of dice. I did Chessex, and I did WizDice, and I've done Gamescience dice. And the next dice we're going to look at, and again you'll see I've done the sheet. The Chessex, or on the WizDice, like I did on the Chessex. And let me clear this out here. These are the WizDice. Now, again, and I've measured the thicker and the thinnest parts of the die, and I come up with the difference between the thicker and thinnest. And the first thing that'll stand out to you is that the WizDice are more lined up. There's less of a difference in the thickest and thinnest sides compared to the Chessex, which makes me think at first, well, these are going to be more accurate. They probably didn't tumble them as much, and therefore the thickness of the sides are not that much off. But I noticed something when I look back at the measurements of the faces. Is that on the measurements of the faces of the WizDice, let's look at example on the red one. It's the fourth one in the columns. Um, the area of the 5 compared to the area of the 16, the area of the 5 is bigger than it is on the area of the 16. And then the 5 itself is lining up with the 9 and the 12 almost. It's just a little bit bigger. It tells me that when this die was tumbled, it was tumbled really unevenly. There's something wrong with that die that it was tumbled unevenly. And, we look at the middle one, and, the difference on the middle one is fine because, again, it's the blue is smaller than the red, but again, the sides of the dies are. It just stands out to me like that 5 and that 16 that they're off. If they were tumbled evenly, those numbers should be closer together, and that really has me bothered a little bit by the WizDice. Now, the WizDice themselves, when I tested them in the water, you'll notice that a point came up instead of a flat side, and the reasoning for that is that these are plastic molded injected, and any plastic molded injected die has a tendency to get vacuum bubbles in the die itself, and the way those are formed is when they put this plastic in at 2000 psi, the outside of the die cools a lot quicker than the inside. So when the inside starts contracting, it's pulling against the outside, and the outside's not going to give because it's already hardened. So it pulls open a little pocket of missing material, and that pocket is those bubbles that you see, and it's a vacuum inside there. Now, when you're rolling your die on your tabletop, it doesn't really affect it very much. Or actually hardly at all, because I did roll dice like this with bubbles in them a thousand times, and it didn't affect it at all. But when I put it in the water, it does affect, because the water is more sensitive to weight distribution in the die. So the areas where the bubbles are at popped up more, and the reason why I know there's a bubble in there because it didn't pop up to a flat face. If there wasn't a bubble in there, it would have popped up to a flat face, and it popped up to a corner instead. So that was showing me that there was a bubble in there. Now, I've always said this. You can see the inside of your die with the translucent die. You can see if there's these little vacuum bubbles. If that bothers you, then by all means get translucent dies. But to me, that's not enough to disqualify a die from being played as far as having those bubbles. I think they're still accurate, and as far as the WizDice though, I'm more worried that the shape of the die is off, because you can tell the area of the die is off, and that's one of the things that's kind of bothering me about the WizDice. Let me switch over to the next set of dice here. Okay, this will take me just a second. Sorry about this. Okay, let me get my other file loaded. Okay, next set is Gamescience, and again, you'll notice I've done the measurements, the facial measurements up here, and then the other measurements at the bottom. So let me flip over to our first measurements here. Now, you'll notice I did do the thinnest versus the thickest, and then I did come up with the difference down here at the bottom. So let's look again here at the bottom. The other dice were hundredths of an inch thick. Now, a hundredth is a lot thicker than a thousandth. Because they are decimal places. So it's, the hundredths, the tenths are thicker than hundreds, and hundreds are thicker than a thousandths. So these dice are only off by that one, 8 thousandths of an inch. This one 5 thousandths of an inch, another 5 thousandths of an inch, and another one that's 5 thousandths of an inch, and the next one is 6 thousandths of an inch. So that compared to the ones that are off, 20 hundredths of an inch, these are a lot more accurate than the other ones. And the reason why they're off at all is because when you inject plastic and it's hot, and we know as things cool down, it contracts. Well, there's about 2.2% uh, um, contraction in the die, so that's where you're getting this fine amount of differences that we're seeing in these dice in the measurements is because there is that 0.2% of shrinkage, and it's actually very random. If you look at the dice, there's no pattern here for which face shrunk more than the other, which is really good. Now I want to switch over back to the other measurements, and this is pretty cool that I've noticed here with the Gamescience dice. When I measured these faces on these Gamescience dice, you'll notice that I only put one number under each face instead of a number on each side of the face. That's because each number on the sides of the face are all equal. And then if you look under each column of dice, they're all like the number 1 on the clear is 0.503. The number 20 is 0.503. They're all 0.503. I did only have 2 that were off on one face per dice. If you look at the yellow die on face 14 versus face 7, face 14 is smaller by 1 thousandth of an inch. And then if you look at the pink one, it is off on face 13 and face versus face 8, another 1 thousandth of an inch. That is very accurate. So what I did was just did the area across for each die. So the area on each face is going to be the same of for each face. So what happens with this, and this is the great thing about Gamescience, is that now you have all the areas on the face the same. The center of gravity for each face is the same. So when this die rolls, you're going to get a better opportunity to get a true random number, which is what you want for this game. You don't want skewed numbers because it actually ruins your game in the long run. So as you're playing here, you're going to get true random numbers because your faces are equal and your center of gravity is the same versus if a side was thinner than the other side. And now the thing about the edges, and I like to point this out about the edges, on the Chessex and the WizDice, you have a rounded edge. Well, you don't have a rounded edge on a Gamescience die. Now, and there's a reason for this, and this is another reason why casinos don't have rounded edges either. When you roll a die with a rounded edge, it gives that die more of an opportunity to find its center of gravity if the center of gravity is off versus if a die doesn't have a rounded edge. So people are like, oh, these dice roll great. Look how far it rolls. Look how long it rolls. That's not a good thing in dice. You want a die that when you roll it, it comes to an abrupt stop. That abrupt stop, and the reason being is it's not going to spend all this time looking for its center of gravity. I've literally rolled D20s. It's taken 10 seconds for it to stop, and that's just from where it's bouncing in one spot, and that's not good. You don't want that. You want the dice to, when you drop it, it tumbles once or twice and it stops. And that's another reason why casinos have edges. For gaming law, you have to have the dice have to be made out of a solid piece of material, and that piece of material has to be milled. So they have to mill it within I don't remember what the actual measurements are, but it has to be a certain specification in each side. So when you mill this out, there's no shrinkage because it's not plastic molded injected. Now for the pips, the dots, it's for the so there's not a problem with weight. That plastic in the dots is the same plastic that's in the actual die. It's just a different color. And so what they do is they drill out the places for the dots, and then they put the plastic in, and then they cut the plastic out and remill it down, so that we now know the die is equal on all faces. If you can ever get a chance to get a set of casino dice, they're really nice to have. I use them because I play Warhammer, so I'll use casino dice because you can buy them in bulk fairly cheap sometimes. So in conclusion, my number one choice for dice is always going to be Gamescience. They're great dice to have for their price. They're great compared to the milled options that you're getting nowadays. They're literally a tenth of the price. My second dice are probably still, even though they're the unevenness of the die, probably will be the WizDice because of the translucents perform a little bit better in water than the Chessex do. The I use a dice tower, so a dice tower helps out with that a lot. There's not a lot of crazy rolling going on there. I probably will not play with Chessex again after all these testing I've done, just because I can see how bad they're off. I'll probably buy Chessex, but it'll be for decoration, such as making lamps, and my daughter makes jewelry out of things like this. So, she'll probably use dice to make jewelry with, and I'll let her have the Chessex to do that. But as far as a good dice, the Gamescience to me overall are the best dice. They're random compared to other dice. And they're higher quality, the high impact plastic. I've done testing on how much stress the plastic can take by dropping a weight on the dice. When I drop it on the Chessex, they explode. When I drop it on a Gamescience dice, it just takes it like a champ and keeps going. And the plastic itself was designed to is high impact plastic, and the reason there was a reason that high impact plastic was chosen. High impact plastic was picked because when TSR first started getting dice, they were getting really cheap dice out of Taiwan, and within a few months, these dice, the edges were chipping, they were wearing down, and people would have to go out and buy another set of dice. Well, the owner of Gamescience is like, well, I'm just going to start making them out of high impact plastic, so that the dice doesn't wear out as quickly, and people started buying his dice because again they didn't wear out as quickly. They lasted a lot longer, and they actually have a warranty on the die. I believe it's like if the die wears down within 2 years of play, they'll replace the die for free. I've never seen anybody actually have a warranty on dice like that before, so it's another reason to look at it. And I will let you know also on the gem dice from Gamescience. Their gem dice are not. They're made out of a different type of plastic. It's still a high impact plastic, but it's actually polycarbonate. The same stuff that you make your eyeglasses are made out of. So you've got the gem dice are polycarbonate, and I mean they're crystal clear, and they're really pretty dice compared to other dice. Again, Gamescience all the way, then WizDice, and then Chessex. If you have any questions or comments, just put them down below, and happy gaming.